All right, let's talk about the next massive leap in how we connect to the internet, Wi-Fi 7. Now you might hear it called by its technical name, IEEE 802.11be, or my personal favorite, its official title, Extremely High Throughput. And trust me, as you're about to see, that name is absolutely earned.
So, here's what we're going to cover. We'll kick things off with the big question. Why do we even need Wi-Fi 7 in the first place? Then, we're going to pop the hood on its new toolkit and get into the real game changer, something called multi-link operation. After that, we'll see how it's not just about speed, it's about being smarter. We'll even do a quick dive into the nitty-gritty of how it all works before looking at the incredible future this tech is going to unlock.
Okay, so first things first. Why now? Why do we need this huge upgrade? Well, it's pretty simple, really. The demands we're putting on our current Wi-Fi networks, they're starting to push them right to the breaking point.
I mean, just think about it. It's not just about checking email anymore, is it? We're streaming multiple 8K videos at once, we're getting into truly immersive AR and VR, and we're playing cloud games that need a response time that's practically instant. The amount of data our homes and businesses are trying to handle is just exploding. And these new things we want to do, they don't just need speed, they need incredibly low latency.
And, the numbers here are just staggering. This isn't a small incremental update. It's a massive, massive leap. We are looking at a theoretical peak speed of 46 gigabits per second. That is almost 5 times faster than Wi-Fi 6. And this incredible jump, it's all thanks to some huge upgrades happening across the board.
So, the big question is, how on earth does Wi-Fi 7 pull this off? Well, it's not just one single magic trick. It's a whole new toolkit of really advanced technologies all working together. So let's break them down.
Okay, the most straightforward upgrade is just making the data lanes wider. A lot wider. Wi-Fi 7 doubles the maximum channel width, all the way up to 320 megahertz, using that new 6 gigahertz band. The best way to think about it is like upgrading a road from 2 lanes to a 4-lane superhighway. More lanes mean way more data can flow through at the exact same time. It's a huge boost in capacity.
Next up, Wi-Fi 7 gets a whole lot smarter about how it packs your data into each and every signal. It uses this new, denser method called 4K QAM. Now that stands for Quadrature Amplitude Modulation, but all you really need to know is this. It lets each signal carry 12 bits of data instead of the 10 bits it could before. And the result? A straight-up 20% boost in data rates, just from this one change.
And the upgrades just keep coming. Wi-Fi 7 also doubles the number of spatial streams up to 16. You can think of that like doubling the number of antennas talking to your devices all at once. It also puts existing technologies like MU-MIMO and OFDMA on steroids. These are basically the air traffic controllers for your network, and now they're way, way better at managing dozens of devices at the same time without everything grinding to a halt.
Okay, now let's get to the main event. If there is one technology that really defines what Wi-Fi 7 is all about, it's this one. It's called multi-link operation, or MLO. And honestly, it's probably the most innovative and disruptive feature in this whole new standard.
So here's the deal. For the very first time, MLO lets a single device, like your phone, connect to a router using multiple frequency bands, say the 5 GHz and 6 GHz bands, at the exact same time. Before this, your laptop or phone had to pick just one band and stick to it. Now, it can use them all together.
And the impact of this is just huge. You get much higher speeds because you're literally combining the bandwidth from different bands. It massively lowers your latency because it can send really important data over whichever link is the fastest and clearest at any given microsecond. And your connection becomes way more reliable because it can just dynamically dodge interference by switching links on the fly. So think of it like this. Your data used to be stuck in a single lane of traffic. And if that lane got congested, well, tough luck. MLO basically opens up multiple highway lanes at once. Your device can then bundle all those lanes together for maximum speed, or it can intelligently steer your data packet down the clearest path to avoid any traffic jams. It's brilliant.
But here's the thing, Wi-Fi 7 isn't just about brute force and raw power. It's also about being incredibly intelligent and efficient with how it uses the wireless spectrum, which is especially important when you're in a crowded apartment building or office.
A perfect example of this is a feature called multi-RU. See, with Wi-Fi 6, the network could only give one slice of bandwidth, what's called a resource unit, to a single device. Wi-Fi 7 is way more flexible. It lets the network assign multiple slices to the very same user, which means there's a lot less wasted bandwidth. It just makes the whole network run more efficiently.
All right, now check this out, because this next feature is incredibly clever.
Imagine your brand new Wi-Fi 7 router has a huge 320 megahertz channel all ready to go. A massive, wide-open highway just for your data.
But what happens if just a small piece of that highway, let's say a tiny 20 megahertz slice, is being blocked by interference from your neighbor's network or maybe an old cordless phone? Well, in the past, this was a huge problem. That one little bit of interference could make that entire massive channel completely unusable.
Wi-Fi 7 has a genius solution for this called preamble puncturing. It intelligently finds that blocked section of the channel and just punctures it out, like cutting a hole in paper. This lets all your data just flow around it, using all the remaining clear parts of the channel. So, and this is the crucial point, you no longer have to shut down the whole highway just because of one little pothole in a single lane.
So, how do all these smart features actually talk to each other and work together? Well, to get that, we need to pop the hood and take a quick peek at the foundational code, the MAC and physical layers. This is where Wi-Fi 7 was really rebuilt from the ground up.
Right at the heart of all of this is a totally redesigned data packet. The easiest way to think of it is like a new, much smarter shipping container for your data. This new container is what allows your router and your device to coordinate all of Wi-Fi 7's cool new tricks, like using multiple bands at once or puncturing out interference.
And you know, what's really clever about this new data packet is how it's designed to work with older gear. It has a special signal right at the front that older Wi-Fi devices can understand, so they can still coexist on the same network without any problems. But right after that, it carries all the new instructions needed for Wi-Fi 7 to work its magic. Okay, so let's zoom back out from the deep tech stuff for a minute. What does all of this incredible technology actually mean for us, for our daily lives, and for whole industries? What kind of future is Wi-Fi 7 really building?
This is so much more than just getting your movies to download faster. Wi-Fi 7 is what we call a foundational technology. It's what makes the next generation of applications possible. We are talking about ultra-reliable automation in factories, the digital nervous system for entire smart cities, and the kind of rock-solid low-latency connection you'd need for things like remote surgery and healthcare. It's genuinely transformative.
But, and this is a pretty big but, getting to that future isn't going to be like flipping a switch. As this report points out, there are some pretty significant hurdles we have to get over. The high cost of all this new hardware, different spectrum rules around the world, and just making sure the underlying internet infrastructure can even keep up. These are all real challenges to getting it adopted everywhere.
And really, that leaves us with the final crucial question. The technology for this next great leap in wireless connection, it's finally here. But the bigger question is whether our routers, our internet plans, and our entire public and private infrastructure are actually ready to unlock its absolutely staggering potential.